The year's 1997, and in an open-pit coal mine in Wyoming's Powder River Basin, the O&K RH400 breaks ground for the first time in North America. With a bucket capacity of 45 cubic meters, roughly 60 cubic yards, a boom reach extending over 40 meters, and an operating weight of 980 metric tons, it represents the pinnacle of German hydraulic excavator engineering. The most powerful mining shovel on earth, proclaimed the glossy dealer catalog distributed that year, featuring dramatic photographs of the machine dwarfing haul trucks designed to carry 400 tons. Yet even as operators marveled at its capability to fill those trucks in 3 passes, economic realities were closing in. Caterpillar and Komatsu, with their vast dealer networks and decades of mining relationships, had already positioned competing machines. O&K's brilliance had arrived precisely when the market least needed another manufacturer. How does a company engineer the world's most powerful excavator and still watch its name disappear from the industry? In 1876, 2 German entrepreneurs, Heinrich Otto and his partner Kaiser, established Ornstein and Koppel in Berlin, initially producing railway equipment for Prussia's expanding industrial infrastructure. The company's early decades focused on narrow-gauge locomotives and mining cars, but by the 1920s, O&K had begun manufacturing excavators. The transition reflected Germany's post-World War I reconstruction demands and the Ruhr Valley's expanding coal operations. O&K's first excavators were cable-operated models, similar to American designs from Bucyrus and Marion, but German engineering standards demanded precision manufacturing that became the company's hallmark. The factory in Lübeck, established in 1928, specialized in heavy machinery fabrication, massive steel structures welded and riveted by craftsmen trained in shipbuilding techniques. By the 1930s, O&K excavators appeared in mines across Europe, machines known for robust construction rather than innovation. The company survived World War II's devastation, its factories bombed, but its engineering expertise intact. Reconstruction provided opportunities. Germany's infrastructure rebuilding required excavation equipment in quantities that allowed O&K to rebuild its manufacturing base through the 1950s. Throughout the 1950s and 1960s, European mining operations relied predominantly on cable-operated excavators, machines using steel rope and drum systems to control bucket movement. These systems were proven but limited. Cables stretched under load, reducing precision. Drums required constant maintenance, and cycle times were constrained by mechanical limitations. O&K recognized that hydraulic technology, already transforming smaller construction equipment, could revolutionize mining excavators if scaled appropriately. The engineering challenges were substantial. Hydraulic cylinders capable of generating the forces needed for large mining buckets didn't exist commercially, and hydraulic oil systems operating reliably in cold German winters and hot desert mines required development. By 1965, O&K introduced the RH40, a 40-ton hydraulic excavator designed for quarrying rather than large-scale mining. The machine featured a 2.5 cubic meter bucket and represented O&K's first successful application of hydraulics to excavation above 30 tons. Trade publications noted its smooth operation compared to cable machines, and German limestone quarries provided a testing ground where hydraulic advantages, precise bucket positioning, faster cycles, reduced maintenance, could be demonstrated convincingly. The RH-40's success in European quarries encouraged O&K to scale the technology upward. By 1972, the company introduced the RH-75, a 75-ton excavator with a 6 cubic meter bucket designed specifically for open-pit coal mines in Germany's Rhineland. The Rhineland mines, massive operations extracting lignite coal from seams sometimes 300 meters deep, demanded productivity that cable excavators struggled to deliver. O&K's engineering team, led by hydraulic specialist Werner Schultz, who had previously worked for Mannesmann Rexroth, developing industrial hydraulic components, designed a system using multiple hydraulic pumps driven by a single diesel engine. This allowed independent control of boom, stick, and bucket functions while maintaining the power needed for mining-scale operations. Early operators praised the machine's responsiveness, though reliability concerns emerged. Hydraulic seals failed more frequently than O&K anticipated, and hydraulic hose routing in the boom structure proved vulnerable to abrasion. "Impressive when it works," noted a 1973 dealer report from the Rhineland. "But downtime costs are significant." O&K spent the next several years refining hydraulic system design, gradually building confidence that large hydraulic excavators could match cable machine reliability. The transition from cautious hydraulic adoption to aggressive market expansion came in 1979 when O&K introduced the RH120, a 120-ton excavator with a 12 cubic meter bucket that decisively proved hydraulics could handle serious mining applications. The RH120 featured redesigned hydraulic cylinders with improved sealing systems, hardened cylinder rods that resisted scoring, and hydraulic lines routed through protected channels in the boom structure. More critically, the machine demonstrated productivity advantages that mining operators couldn't ignore. Cycle times averaging 28 seconds compared to 35 to 40 seconds for comparable cable machines, and bucket positioning accuracy that allowed operators to load haul trucks more efficiently. Australian coal mines in Queensland's Bowen Basin became early adopters, ordering RH120 units that proved capable of handling the region's abrasive coal seams and harsh operating conditions. O&K's dealer network expanded accordingly, establishing service centers in Brisbane and establishing parts inventory sufficient to support machines operating in remote locations. Yet even as RH120 sales grew, approximately 45 units sold between 1979 and 1985. Caterpillar and Komatsu were developing their own large hydraulic excavators, studying the market O&K had validated through its engineering investments. By the mid-1980s, O&K faced strategic choices about continuing to scale hydraulic excavator technology upward. Mining operations worldwide were growing larger, with haul trucks increasing from 150-ton capacity to 240 tons and eventually 320 tons. These massive trucks required excavators capable of filling them quickly, ideally in 3 to 4 passes, to optimize productivity. O&K's response was the RH200, introduced in 1987, a 200-ton excavator with an 18 cubic meter bucket specifically designed for ultra-large mining operations. The machine represented a significant engineering leap: hydraulic cylinders with 320 millimeter bore diameters, hydraulic systems operating at pressures exceeding 350 bar, and a structural framework requiring new steel specifications to handle the loads involved. Testing occurred at lignite mines in eastern Germany, where the RH200 demonstrated it could maintain cycle times under 30 seconds, while moving dramatically more material per cycle than the RH120. "The machine works beautifully," reported a mine superintendent in a 1988 operator survey, "but the capital cost is substantial. At approximately $4.5 million, the RH200 cost nearly double what a comparable cable machine would, and mining companies had to justify the investment through productivity gains that weren't always immediately apparent." The success of the RH200 in European mining operations encouraged O&K to pursue what many competitors considered impossible: a hydraulic excavator exceeding 500 tons operating weight. Development began in 1991 for what would become the RH400, a machine designed from the ground up to compete with the largest cable excavators ever built. O&K's engineering team, now numbering over 80 specialists focused exclusively on mining excavators, designed hydraulic cylinders with 400 millimeter bores, the largest ever specified for mobile equipment. The boom structure required finite element analysis to optimize steel placement, balancing strength against weight in a structure that would extend over 40 meters and lift buckets holding 45 cubic meters of material. Hydraulic system design consumed 2 years of development. Managing the heat generated by systems pumping 4,000 liters of hydraulic oil per minute required sophisticated cooling systems. The first RH400 prototype underwent testing at a lignite mine near Cologne in 1996, where it demonstrated jaw-dropping productivity, filling a 320-ton haul truck in under 3 minutes, moving over 4,000 bank cubic meters of material per hour under optimal conditions. O&K had engineered a genuine breakthrough, a hydraulic excavator that could match or exceed the largest cable machines ever built by Marion and Bucyrus. The RH400's commercial introduction in 1997 generated substantial industry attention. Mining publications featured the machine prominently, and O&K's marketing emphasized unprecedented productivity combined with hydraulic precision. The company secured initial orders from coal operations in Wyoming, Australia's Hunter Valley, and South Africa's Mpumalanga province, operations large enough to justify the machine's approximately $7.5 million price and sophisticated enough to manage its maintenance requirements. Early operational results validated O&K's engineering claims. At a Wyoming coal mine, the RH400 consistently filled Caterpillar's 793 haul trucks, carrying 240 tons in 3 passes, averaging 25 seconds each. "Never seen anything load this fast," noted an experienced operator in a dealer testimonial preserved in O&K's archives. The machine's hydraulic system provided precise bucket control that allowed filling trucks evenly, maximizing payload without spillage. Yet, even as these early successes accumulated, market realities were shifting beneath O&K's achievement. Caterpillar had been developing its own large hydraulic excavator, the 5230, and announced its introduction in 1998. Komatsu similarly revealed plans for hydraulic excavators exceeding 500 tons. Both companies possessed advantages O&K couldn't match: global dealer networks with parts distribution to every major mining region, service technicians numbering in thousands rather than dozens, and financial resources to support aggressive pricing strategies. Between 1998 and 2000, O&K manufactured approximately 15 RH400 units, a respectable number for ultra-large mining equipment, but insufficient to establish market dominance. Each machine sale represented a victory of engineering excellence over market skepticism, but also exposed O&K's fundamental weakness. Supporting these sophisticated machines required dealer infrastructure the company simply hadn't built. When an RH400 experienced a hydraulic pump failure at a remote Australian mining site, replacement parts sometimes required weeks to arrive from Germany. Caterpillar, by contrast, maintained parts inventory in every major mining region and could often deliver critical components within 24 hours. Mining operations running 24/7 schedules couldn't tolerate extended downtime. Every day an excavator sat idle represented tens of thousands of dollars in lost productivity. O&K attempted to address these concerns by establishing regional parts warehouses and training local mechanics. But these efforts required investments the company struggled to finance. The RH400's technical brilliance became irrelevant when operators calculated total ownership costs, including downtime risk. As one mining equipment manager explained to a trade publication in 1999, "The O&K loads faster, but if it breaks and I'm down for a week waiting for parts, I've lost whatever productivity advantage it offered." By 1999, the RH400 represented both O&K's greatest engineering achievement and its most visible vulnerability. The machine had proven the company could compete technically with anyone, but market dynamics were demonstrating that technical excellence alone didn't ensure survival. Caterpillar's 5230, introduced in 1998, featured specifications remarkably similar to the RH400, bucket capacities between 40-45 cubic meters, operating weights near 900 tons, similar productivity ratings. The critical difference wasn't in the machines themselves, but in the support infrastructure surrounding them. Caterpillar's dealer network spanned every continent with major mining operations, parts warehouses, stock components for every system, and service technicians trained on hydraulic excavators numbered in the hundreds. When mining companies evaluated excavator purchases, these factors increasingly outweighed machine specifications. O&K secured approximately 3 RRH400 orders in 1999 compared to over 20 52-30 orders for Caterpillar. The market was rendering its judgment not on engineering quality but on total value proposition. O&K had pioneered large hydraulic excavators and proven the concept commercially viable. The reward for this pioneering work was watching competitors with superior market positioning capture the category O&K had created. The mining equipment market contraction that began in late 2000 devastated manufacturers exposed to narrow product lines and limited geographic diversification. O&K's business model, focused heavily on large mining excavators sold primarily to coal operations, proved particularly vulnerable when coal prices declined and mining companies delayed equipment purchases. The company's order book for 2001 included only 2 RH400 commitments compared to 7 in 1999. Manufacturing capacity at O&K's Lubeck facility, tooled specifically for large excavator production, sat largely idle. Fixed costs continued, engineers still needed salaries, factory overhead persisted, dealer support networks required funding, but revenue plummeted. O&K's parent company, which had diversified into other industrial sectors, faced difficult decisions about whether to continue subsidizing the mining excavator division's losses. By mid-2001, those discussions had progressed to exploring potential buyers who might acquire O&K's mining equipment business. Komatsu emerged as the logical acquirer, a company seeking to expand its mining excavator portfolio and willing to pay for O&K's engineering expertise and established machine designs. Komatsu's acquisition of O&K mining equipment in 2002 ended over a century of German engineering independence. The transaction, valued at approximately $400 million, transferred O&K's excavator designs, manufacturing facilities, and engineering personnel to Japanese ownership. Komatsu's strategy was straightforward: rebrand O&K's proven designs under Komatsu designation while integrating them into Komatsu's global dealer network and parts distribution system. The RH400 became the PC8000. Its specifications essentially unchanged, but now supported by Komatsu's worldwide service infrastructure. For customers, the transition addressed the primary concern that had limited RH400 adoption: reliable parts availability and service support. The machines remained excellent, now backed by a manufacturer capable of supporting them globally. For O&K, as an independent entity, the acquisition represented complete erasure. The factory in Lubeck continued operating, but as a Komatsu facility producing Komatsu-branded machines. O&K badges were removed from equipment, replaced with Komatsu's red logo. By 2005, finding an excavator bearing O&K identification became increasingly difficult. Most had been rebranded during routine refurbishment, their original identity obscured beneath new paint and decals. The final O&K badged RH400 was manufactured in 2003, completing an order placed before Komatsu's acquisition. This machine, delivered to a South African coal mine, represented the last physical artifact of O&K's mining excavator ambitions. The specifications that had seemed revolutionary in 1997, 45 cubic meter bucket, 9 or 80 ton operating weight, 4,000 cubic meters per hour productivity, had become industry standard by 2003, with multiple manufacturers offering comparable machines. O&K had successfully pioneered large hydraulic mining excavators, validating the technology and proving its commercial viability. The market responded by commoditizing the category, with established manufacturers leveraging superior scale and infrastructure to dominate sales. O&K's legacy became anonymous, absorbed into Komatsu's ongoing product development. Former O&K engineers continued working on hydraulic excavator advancement, but their contributions now appeared under Komatsu authorship. The company that had risked everything to develop the RH400 received no lasting recognition for transforming mining excavator technology. Today, hydraulic excavators dominate large-scale mining operations worldwide, having completely displaced cable-operated machines. Every manufacturer producing mining excavators, Caterpillar, Komatsu, Hitachi, Liebherr, offers models descended from concepts O&K pioneered with the RH400. The hydraulic system architectures, the structural engineering approaches, the productivity optimization strategies, all trace lineage to innovations O&K implemented first. In equipment museums and private collections, a handful of O&K excavators remain preserved, their faded paint and worn hydraulics testament to machines that worked hard in difficult conditions. The RH400's engineering excellence is undisputed among equipment historians. Its commercial failure, or more accurately, its inability to secure lasting competitive advantage despite technical superiority, serves as a case study in industrial economics. Great engineering proves categories viable. Market infrastructure determines who profits from the proof. O&K demonstrated what was possible. Competitors with better distribution networks and deeper financial resources captured the market O&K's innovation had created.